Hello, everyone, and welcome to SPE Live. This is our final SPE Tech Talk of the year, so thank you so much for joining us. For everybody out there watching, it's been an absolutely amazing year of doing SPE Tech Talks, and we have saved the best one for last. All right, today joining us is Schlumberger, and we're going to be talking about high-temperature, water-based drilling fluid systems. This is definitely an interesting topic for me because, as always, like I like to say, I'm a little bit more on the drilling side than anywhere else. So I might actually be able to learn something that I could apply and go forward with. So it's going to be a great show. Thank you all for being here. I didn't know if I said it. I'm your host, David Gibson, right? Last one of the year, and I'm just going to mess up all the things that I normally do say. So for everybody out there that's watching, we are doing this live, and we're doing this live so that we can interact with you, the audience. Right? So be sure to comment. Just, it's not going to take very many calories, and it's almost the beginning of the year. So, you're going to have these New Year's resolutions. Let's make the New Year resolution that you burn the most calories typing in your name and letting us know where you're watching from in the comment section right now. We'll be sure to get to those. We'll give you guys a shout out here on the screen. So let us know, is this the first SPE Tech Talk that you've joined in on? If not, let us know which one was your favorite of the year so far, or which one was the most memorable that you've watched. Would love to be able to get that information as well. Trying to think of anything else. Yes, I'm overwhelmed that this final show of the year. This is really exciting. So be sure to let us know where you're watching from. If you've got any questions or any comments as we go through the show, please be sure to put them out there. We've got an expert coming in to be able to answer your questions specifically. Right? They are here for you. So be sure to fire off all of the brain busters that you may have. All right, let's get started. In this Tech Talk, our conversation focuses on a new system for high temperature drilling fluid, logging fluid, and similar applications, plus some of the examples of how this system has sustainable benefits. Joining me is Mr. Bala. He is a technology project manager for Schlumberger. Bala has a PhD in polymer chemistry and has spent more than 14 years working in oil and gas, mostly in fluids, whether drilling, reservoir, or completions. Bala, welcome to this last SPE Tech Talk of the year, and look forward to learning more about this technology.
Oh, thanks, David. Thanks for having me. I'm extremely proud and happy to participate in SPE Tech Talk. Thanks again for having me today.
Well, we are absolutely elated to have you here. I know we've got tons of people watching from around the world. We'll get to you guys in just a minute. First, we have to be able to set the stage here with Bala. All right, Bala, what are the technical challenges for high temperature drilling fluids?
It's a great question to start off, David. We should know the technical challenge before we put our efforts towards product development or fluid design. There are several technical challenges for high temperature. As you mentioned, today I'm going to focus on water-based drilling fluid. So I'm going to talk about the challenge associated directly to the water-based drilling fluid. There are several challenges. At least I'm going to highlight the top 2 or 3 technical challenges. The number one, chemistry. So the very common viscosifier we use in the system, which we used below 300 degree Fahrenheit, are biopolymers like xanthan gum or diutane gums. These chemistries are amazing. It provides great low end rheology. That's what we need for drilling fluid. But these polymers are not stable above 300 degree Fahrenheit. It undergo hydraulic degradation. Simply, it's not stable. We can get some stability by using lot of other stabilizers like ethanolamine family or formate salt or like pH buffers, but and also continuously treating during drilling. But that will not provide long-term stability. And also that's not a sustainable way of treating the fluid. So the biggest challenge I can say is a chemistry for. The second one, density. The density is not directly related to the temperature, but usually when the temperature increases, density also increases. You all know that for water-based mud system, we get the density by 2 ways. One, adding the weighting material like barium sulfate or hematite ore to the water to get the density. The other way is adding salt water, there is a brine, to get the density. But having brine for density purpose is a very limited application. So let's focus on the other one, adding weighting material to get the density. So when the density increases, the amount of weighting material also increase. If it goes beyond certain threshold, let's say 14 pounds per gallon, the amount of weighting material in the fluids are really high. The higher weighting material causes more rheology, viscosity. Higher viscosity brings a lot of technical challenge. One, it will not allow, it will not easily separate the solids at the shaker. The another very, very biggest is it increase the equivalent circulating density, ECD. Once ECD increase higher than fracture gradient, it induce the fracture. So we always stabilize the rheology. The third one is long-term stability. So for at least for drilling fluid, you can able to treat the fluid every circulation, but we don't want that, but at least we can do it. But for logging fluid, you need the long-term stability. So these are the biggest technical challenge if I associated with high temperatures. Apart from that, there is logistic issue. Sometimes for high temperature drilling fluid, people use a lot of chemicals. If more chemicals, it bring more logistic issue. So I can think these are the biggest technical challenges associated with the high temperature, David.
Well, that is no short of challenges. Those are definitely challenges that I probably myself couldn't overcome. I've got another follow-up question for you here, but first, I want to be able to say hi to everybody that we've got watching from around the world. So we've got Ahmad that said hello, Durat that said hello. Carol says she's watching from Charleston, South Carolina, and this is her first time here. Sadiq said hello. Prince watching from Congo. Marco said hello. Wow, a lot of people saying hello. Let us know where you guys are watching from so we get an idea of, like, how big this, we got to make Bala nervous with all the people watching from all around the world, right? Mohammed said hello. Ellis Savurs from Azerbaijan. Sorry, I didn't say that one. David from Spain. Sarath says he actually knows you, Bala. He's watching from Doha. Charlemagne from Gabon. Ismail from DZ. I'm not sure what that one is. I don't know, Bala. Maybe you have to help me out with that. You've got a better education than I do. Marco from Ecuador. Michael from Aberdeen, Scotland. Greetings from Saudi Arabia from Abdullah. El Salvador, and then Mohammed from Algeria, Akinla from Lagos, Nigeria, Sankit from Abu Dhabi, and then Russell from Stavanger, Norway, and then Cecil from Norway as well. Wow, there's a whole bunch of them just busting in right there at the end. Everybody's challenging me with my pronunciations today, so thank you all so much for being here, and please do not feel slighted by my inability to pronounce names. I'm not very good at reading. So anyways, all right, Bala, you told us about some of the technical challenges of being able to create these high temperature drilling fluids, or the technical challenge that they're going to go through, as well as an extra challenge in there in logistics and supply chain, which we know we're all dealing with right now. I'm trying to buy, presents for the kids and stuff, and having to figure out that I'm already way too late with that. So how do you design to overcome these challenges in being able to develop these high temperature drilling fluids?
Okay. So I will, it's a great question, right? How I designed. So I will go with the same order, which I talk about the technical challenge. I start with chemistry. I said biopolymers like xanthan, diutanes are amazing polymer, right? Why it is amazing? Because it provides a great low-end rheology. That is the main need for drilling fluid, because if you have good low-end rheology, it carry all the drill cuttings from the downhole to the surface, keep the hole very clean. One of the main properties of xanthan is the branching nature. Okay, then the issue is stability. That's here. The second one is synthetic polymer. We have synthetic polymer in our industry for more than 25 years. Synthetic polymer, with fine tune, you will get a great stability. But the problem with the synthetic polymer, which are available in the markets, are linear. If it is a linear synthetic polymer, that will not provide good low-end rheology. It provides stability, it will not provide low-end rheology. Xanthan Good low-end rheology, synthetic polymer stability. What we did was we just combined. We didn't combine the chemistry, we combined the concept, idea. What we did was we make the synthetic polymer into branched synthetic polymer such that that synthetic polymer provides stability and good drilling fluid properties. That's the number one. The second things, like I talk about density. So we came up with a very good dispersant. So the dispersant will disperse the solid and stabilize the rheology. So when you talk about dispersants, that's what I always tell. Make sure that dispersant is compatible with the calcium. Some dispersants are great, works great at low temperature and no calcium, but at high temperature it undergo hydrolysis and it gives some carboxylated group, then it will react with calcium and precipitate. Make sure you test all these things, make sure that dispersant is compatible with calcium. That's what I did. The third things what I did was make sure that the chemistry which we develop is compatible with all the salts. We don't know, in some location we use sodium salt, some location we use calcium salt, you may drill some anhydride. Make sure that chemistry which you developed should be compatible with most of the salt so that you can use this polymer for different application. The fourth point is long-term stability. When I designed this fluid, there is a Veravis, we call Veravis, that is the branched synthetic polymer. The system we call as a Verathome. When we designed this Veravis and Verathome, we tested the long-term stability, 7 to 14 days at very high temperatures. So these are the few points I kept in our mind when we developed this Verathome systems. Thanks, David.
Excellent. Okay, so now we've got what are the technical challenges, how y'all designed to be able to overcome this. What are the sustainable benefits of designing these types of drilling fluids?
Oh, great. For this question, David, I would like to give some live example. Okay, in Australia, I can give maybe 2 or 3 example. Okay, I will start with the case study from Australia. A client in Australia were using high temperature synthetic basement to drill the high temperature wells. Those area has a natural fracture of inch to even big fracture. Because of that, they lose around like 5,000 up to 10,000 barrel of synthetic basement per well. You see, 10,000 barrel, lot of cost to the client, right? So we proposed Verathon to the client. The client asked a lot of lab testing. We did the lab testing. Finally, a client decided to drill their high temperature well, use Verathon. That it went very well. Yes, because of the fracture, we lost around 10,000 barrel of Verathon. But if you compare the cost of Verathon versus cost of SBM, the cost of Verathon is cheap. So it's a direct cost benefit to the client. The very important, the second point I would like to highlight is when they were using synthetic base mud, they cannot mix the fluid in the rig. They mix the fluid in the liquid mud plant, that is in the land onshore. Then they have to bring the fluid to the offshore. Think about 10,000 barrel. The boat transit from to and fro from LMP liquid mud plant to the rig so many times. So by using Verathome, we mixed the Verathome in the rig. It saved a lot of carbon. It reduced the carbon reduction significantly. What we are doing now is we came up with a sustainability calculator to quantify the sustainability benefit. I'm not going to talk about that calculator in this session. We are planning to present that sustainability calculator soon. So today I'm going to give the points where Verathome brings a lot of sustainability value, and the quantification I will talk in the next session. The second example is again in Middle East. Before, the client was using some water-based mud, but it don't bring the long-term stability. During logging operation, the client, what they do is every day or alternative day, they treat the fluid. So they do the viper tripping and treat the fluid. So the number of days for logging increased. When they start using Verathome is stable for at like 380 Fahrenheit. That's a client's temperature. We pumped it. The fluid is stable for 9 days at 380, no treatment. So it saved number of days for logging. The third sustainable benefit from Verathome is, again, the client in Middle East. They used Verathome to drill the same fluid for 5 high-temperature wells. That means less number of chemicals and also less volume of fluid to dispose. That also bring a lot of sustainable benefits. It's only limited. There's a lot of sustainable benefit Verathome brings to this environment. Thanks, David.
I have to say, you guys couldn't see my face, but when you said that they used the same drilling fluid for 5 wells, I just pure shock over my face to know that the drilling fluid. So I have a follow-up question to that. So what are they having to do as far as I don't want to say treatment, but for qualification, or just to be able to make sure that they can reuse this? Are things messed up when it goes to the shakers, desanders, desilters, degassers? Are these having effects on it? Is this able to stay in the drilling fluid in a closed loop system?
Okay, that's your question is very valid. This Verathome is not different from other water-based mud system, right? So we want to utilize solid control equipment properly to maintain the amount of solid in the drilling fluid as low as possible, right? The more drill solids brings more rheology. You can stabilize the rheology, but I can tell David, we always have to use solid control equipment properly to reduce the solid control. Yes. So Verathome is not different from other water-based mud system. We have to use the same solid control procedures for Verathome.
It's always important, because like if you start doing things differently and you don't make sure things are done properly, then you can the mud guy always ends up getting the blame, right? So yeah, we want to make sure that if you're going to spend the time and energy and all the research obviously that you've done, we got to make sure that all of the other parts of the mud system are being taken care of properly so we don't mess things up. All right, so we've got a couple of comments and questions. Everything's going real lively today. I've got one other question for you from myself before we move forward. To be able to qualify what we consider to be a high temp drilling fluid, what would you say that is?
So in order to qualify, like I mentioned, that stability, right? That's what we do. How to qualify? Hey, this is the system. This is the fluid system. Qualify for this location. One thing is like others, make sure the chemistry or any chemicals is properly registered for that location. Then thoroughly test it. Make sure this system is stable. Make sure the system is compatible with the contamination which we're going to see in that during the drilling. That's what we do. Test it properly. Make sure the fluid is stable, compatible with all the contamination which you think you're going to see during the drilling.
Okay, so Saratha here has got a couple of questions. So we'll hit one of them, let you go, and then let you answer. Okay, does the disperant, I don't know how to pronounce that word. I've never even seen it before, right? This is disperant you have developed work with all weighing agents. Barite, I have heard of that one. Hematite and CaCO3.
It's a carbonate, calcium carbonate.
Oh, okay. There we go.
Thanks, Sharad. Yes. Frankly, I didn't test it with the hematite, but the dispersion which we have developed, we have tested with barite at different barite, barium sulfates. Yes, we have tested calcium carbonate. And also we have tested at a different concentration of calcium. That's what I mentioned it. Sometimes the dispersions was great at no calcium. But when you add calcium, the performance of dispersion goes away. So the dispersion we already field tested, which works great for at least for barite and calcium carbonate, Sharad, at high temperature.
Okay, now Sarath is obviously the student of the day. He's got a second question with his hands up. All right. Does this new polymer work in divalent? I don't know. Once again, brines also completion and also for completion fluids.
Thanks, Sharad. This is important things. Yes, the polymer which we have developed, we called Veravis. When we design this is what we kept one of our requirement. Make sure that polymer is works in all the completion brine, which include sodium chloride, sodium bromide, calcium chloride, calcium bromide, formate brine, even in zinc bromide brine. Yes, this polymer is compatible with all the brine. There is some limitation. I can say that in calcium bromide, this brine will not works in 14.2. It works up to like a 13.7 or 13.8 because it needs some free water to hydrate it. But otherwise, this polymer works in all the oil field completion brine. In monovalent brine, it works up to saturated. In divalent brine, near saturation. And formate brine, it depends upon the brine. Some formate brine, it works even up to saturation. Some brine, it works slightly lesser than saturation. Yes, your answer to your question, yes, we have tested this polymer for all the completion brines.
And so we've also got a great comment here from David. I can imagine how important are sepalite clays as viscosifiers for these applications, performance on high salt concentrations.
Okay, separate clay is there, but the issue with the high temperature, like what the separate clay which you mentioned is gelation. Okay, at high temperature, the performance at high salt is not great. Okay, mainly if you see high calcium or high salt, any high salt, a performance goes down. The second thing is what we have observed is gelation, particularly at higher density. It comes to great gelations, and the dispersion sometimes is not really doing great job. So if you don't take care of gelation issue, then it's a lot of drilling fluid operation issue comes. So that's the reason my comments is, yes, no doubt, saprolite is great. So we can use a saprolite for both oil-based and water-based. For water-based, you should be very careful. Otherwise, it brings huge gelation issue.
All right, we did get into the questions are just coming in full today. So, Bala, like you are the star of the year to be able to have this many. Like we got everything wrapped up, and now we got a bunch of questions. This is perfect. Thank you all for doing this. Keep the questions coming. What about nanoparticles like silica?
Okay, we have tested a few nanoparticles, not only silica. A few things. I'll go with silica first, then I will answer other chemistries. Okay, the problem with the silica is again at high temperature, once continuous circulation, mainly long-term fluid stability, we are not able to control the rheology. It slowly start and it's going on. There is no end point. That's what we observed it. Because you have to use a certain concentration. If you use a low concentration, the impact is negligible. So you have to use certain concentration to see the real impact. But that concentrations, once you get that concentration, the rheology is not flat. It's increasing with the time. That's we really don't want to see in drilling fluid. So I mentioned that we look into a lot of nanoparticles, not only silica, a lot of other chemistry. Each one has certain limitations. Okay, or one cost also play a role. If you go with other nanochemistries, then some nanoparticles is causing some damage. That's we observed it. It invade into more deep into the formation, and it stick there. It's giving a permanent damage. So there are a few limitations to the nanoparticles. That limitation depends upon the chemistry of the nano. Yeah, we have all the things.
I cannot believe this. Like the number of questions is just pouring in. You are definitely you're getting the crown for this year, Bala. All right. So Mr. Campbell has a question. Apart from generating, oh wait, it just moved. Hold on. Okay. Is the polymer compatible with calcium formate? What would be the max temperature and high temperature, high pressure conditions, HTHP?
Okay. Cesium formate. Okay.
Cesium. Okay. I got that wrong.
Okay. Cesium formate is one of the completion brine. What temperature we have tested, right? We have tested in cesium formate again, it depends upon where we're going to use CCM format, right? So we got a two application. We didn't use it in the field, but at least we got a request from the client to test this polymer in CCM format. I think the both project, the temperature is around 350 degrees Fahrenheit. So we have tested the Veravis polymer in CCM format up to 350 degrees Fahrenheit. But don't think that that's the maximum limit. No. Depends upon the request, we can increase the temperature. For example, in other format brine, we tested up to 370. In sodium bromide, we even tested up to 430 degrees Fahrenheit. So it depends upon the request. We tested at a different temperature, but the data which we have in CCM format is up to 350 degrees Fahrenheit.
Wow. Okay, so we've got some more coming in. I should say this. You answered David's questions earlier. David said many thanks. Do appreciate it. Another LinkedIn user said, David, maybe we do a series about drilling fluids. So, Bala, maybe you're going to have to come back and answer a lot more questions. We did have one question here that goes a little bit outside of what we're talking about today, but all nonetheless a good question. Bala, what's your comment on the test equipment and how antiquated it is sometimes? We make a lot of extrapolation based on simple data. Your thoughts?
Yep, it's I can give my thoughts. There's always right. I cannot say that hey, we have the equipment which can take care of all the testing 100%. I don't want to say that. Yes, still we need a good equipment to test all the conditions which we are seeing in the real case scenario. So what are the equipment at least I have used when I developed this Verathon? When I say I means my team. Okay. So we used normal viscosifiers, but we make sure you use the high HTHP viscosifiers. So you want to see the impact of rheology at temperature and pressures. That's very important, right? So that's what we do. Then fluid loss, we always use both static and dynamic fluid loss. Okay, make sure you use a high temperature. Then we don't use just paper for as a filtration media. We always use a disc. Try to use a disc which match with the permeability of your real case scenario. So these are the very common equipments. In case if you're going to see carbon dioxide or H2S gas, make sure you do those contamination tests. We don't want to hear any news when it takes this to the field. Make sure you test everything. These are the common equipment we use. We didn't develop special equipment. Of course, for shale inhibitions, we use other equipment. But for qualifications of chemistry for high temperature, we use very common equipment which are available in most of the oil and gas service labs.
Who would have thought that the most like commented and probably most watched discussion of SPE Tech Talks this year was going to be with Bala talking about high temperature drilling fluids. All right, Bala, we've got a couple of minutes here to be able to wrap up. We want to be able to give you the final stage. Let us know how people can get in touch with you, because obviously there's still a lot of comments. Somebody even requested your email. How can we get in touch with you and your final thoughts going forward with high temperature drilling fluids?
Okay. We send some link. I think we can share to David. So if you click that link, okay, that's we call as a Verathon page. You can find a lot of technical papers and a lot of case study report in that page. So you can get familiarized with the Verathon. And even in the same page, you can get the contact information. So it will go to our marketing department. Then marketing department will forward the questions and comments to me. So I'm sure SPE team will share that Verathon page link to everyone. So the last comments is, yes, high temperature brings a lot of challenge, particularly in Middle East, Australia, in Gulf of Mexico. So make sure we have a system, the branched polymer that we call as a Veravis, which bringing a lot of benefit. So we are happy to work with you and take this system to solve any technical challenge you have. Thank you. And thanks for having David.
Well, Bala, thank you so much for running the anchor leg this year on SPE Tech Talks and having an absolutely amazing conversation. I mean, it's a little rare that we have more questions and comments and we've got time to be able to go through. So for everybody out there watching, and thank you so much. I really do appreciate it. Please be sure to reach out and follow myself on LinkedIn. Look up Bala, find him on LinkedIn as well. Follow SPE on LinkedIn, on YouTube, on Twitter, and on Facebook. Do all the little algorithm things out there that help us, prove to all of the, social media platforms that we are the best and we deserve to be able to get a little bit further reach. It helps us help your colleagues, friends, family, and everything else. So thank you all so much for being here. Thank you so much. And please be sure to tune in next year. We'll have even more SPE Tech Talks just like this one coming up in the near future. Have a safe and happy holidays and a wonderful new year. And as I always say, know your industry.
Thank you.